Let's suppose we have a function 2x over x squared plus 1. What are the first and second derivatives of f? We are going to use this problem to revise the fundamental concepts that you would need to master a differentiation problem, no matter you are a college, A-level, or undergraduate students. At the end of the video, I will do an overall revision on how and when to use derivatives. So make sure that you don't miss out. First, we introduce u equals to 2x and v equals to x squared plus 1. Then we can express y in terms of u and v. We see that y is in the form of a quotient. Therefore, we can use the quotient rule. Before we can substitute u and v into the equation, we must first find out the derivatives of u and v. Then we can substitute u and v into the equation. Simplifying the numerator, we get a final expression for dy by dx. Now let us move on to the second derivative. This is done by differentiate the first derivative. Since the first derivative is also in quotient form, we can introduce a new u and v, such that we can use the quotient rule. Computing the derivatives of these new u and v, and then substituting into the quotient rule, we get the second derivative. Taking common factors of negative 4x and x squared plus 1 on the numerator, we get an expression for the second derivative of the curve y equals to fx. Having these results on hand, what are the stationary points of the curve y equals to fx? We know that stationary points happens when the first derivative is 0. A fraction equals to 0 when the numerator is equal to 0. So we have 2 minus 2x squared equal to 0. Hence x is equal to plus or minus 1. When x is equal to 1, we have the second derivative being a negative number. This means that x equals to 1 is a local maxima. On the other hand, when x is equal to negative 1, we have the second derivative being a positive number. This means that x is equals to negative 1 is a local minima. As I promised you, we can going to look at the application side of differentiation. Differentiation is a tool to help us identify the gradient of the tangent of a curve at a certain point on the curve. As we might know, a curve is made up of infinitely many straight lines. Based on this information, it is pretty sure that a tangent at a specific point on a curve is unique. The derivative is commonly denoted by dy by dx or f-x. When the derivative is 0 at a point, then that point is said to be stationary. This means that the tangent at that point is a line that is parallel to x-axis. There are three types of stationary point. They are classified by the nature of second derivatives. If the second derivative of that point is a strictly positive number, then the point is said to be a local minima. At a local minima, the curve turns from a decreasing function to an increasing function as x increases. In contrast, when the second derivative is strictly negative, the point is said to be a local maxima. At a local maxima, the curve turns from an increasing function to an decreasing function as x increases. When the second derivative is 0, then the point is said to be an inflection point. At an inflection point, the nature of the function does not change. But what if the second derivative is not defined? How would you determine the nature of the turning point? Leave a comment below for your thoughts. If you do not want to miss the explanation to this, you might well subscribe the channel so that next time when I explain it, you will not miss it.
See you next time.